Hi, I'm Len Epp from LeanPub, and in this episode of the Front Matter podcast, I'll be interviewing Jonathan Boccara. Based in Paris, Jonathan is a software developer and a popular conference speaker and blogger who has a particular interest in making code understandable to humans, as he puts it in his LeanPub bio. You can read his Fluent C++ blog at fluentcpp.com, and you can follow him on Twitter at Joe, that's without an E, Boccara, and I recommend you check out one or two of his talks on YouTube. They're excellent. Jonathan is the author of the recently published book, The Legacy Code Programmer's Toolbox, Practical Skills for Software Professionals Working with Legacy Code. The book is meant to help programmers code efficiently while working with existing code bases, which presents a particular set of challenges for professional developers. As software continues to eat the world, how we deal with legacy code is becoming a more and more common and pressing issue, and Jonathan's book is a contribution to our efforts to address it. In this interview, we're going to talk about Jonathan's background and career, professional interests, his talks in his book, and at the end we'll talk a little bit about his experience self-publishing. So thank you, Jonathan, for being on the Front Matter podcast.
Hi, thank you for having me.
I always like to start these interviews by asking people for their origin story, so I was wondering if you could tell us a little bit about where you grew up and how you first became interested in computers and technology.
Yeah, I grew up in Paris, France, and how I was introduced to programming was back when I was a kid. I was like 12. So today, just to make it clear, I'm a professional software developer. I'm team lead of a software developers team. So I'm basically working in programming. So how I got into that originally, when I was like, 12 or something like that, I had never heard about programming, didn't know what that was about. And like one day, my cousin showed me his programmable calculator. Like that was a cool thing back then. It was like the end of the 90s. And he showed me his little game, like text-based adventure game he had made with a calculator. And I remember you could, like, the thing would ask for your name, like, hi, what's your name? And you could type your name in, and then he would then write hi, and then your name. Like, it would type Jonathan, and it would say, hi, Jonathan, how are you? Do you want to start the game? And I was blown away. Like, I asked my cousin, you did that? You can do those things? And he was like, yeah, and I can show you. So that was the first time I encountered programming at all. And so I tried to like do that, and I remember having a hard time understanding basic concepts like variables and that kind of things. And after a few days, it clicked. And then I heard you could do that also on a computer, and I had a computer at home. So I installed whatever you needed back then to do programming, and I started to do my own text-based odd thing. And I really got interested in that, and then I started to do like games, but with graphical things like 2D games. Nothing really fancy, but the kind of games like 12 or 13-year-olds guy likes to do. So that's how programming became a hobby for me.
And is that what you chose to? Well, actually, I have a question about what you studied in university. So I checked out your LinkedIn profile researching for this interview, and you studied at the prestigious École des Ponts Paris Tech, which traces its roots back to 1747 and is part of the Grande École system in France. And for those listening who might not be familiar with it, can you explain a little bit about how the Grande École system works and how they're different from normal French universities?
Sure. So when you finish I think the equivalent of high school in America, like when you're about 17 or 18, you've got a whole range of stuff you can do, right? And what I did is called prépa, it's a French word. It's like preparation classes. And that lasts for 2 years when you do really intensive maths and physics, essentially. What you've got various flavors, but that's the gist of it. And those 2 years where you cram maths and physics help you prepare for like a national exam, and there's a national ranking with this exam at the end of the 2 years. And depending on your ranking, you can choose what engineering school you can get in. It's a first rank first served basis. So the best schools get taken by the people that have the highest rankings and so on. So that's the basic way that's working. And then the engineering school lasts for 3 years. And the really intensive part is the first 2 years where you basically work all the time. I'm really happy to have done that. I wouldn't like to do it again because you work so much, but it's within human reach. It's a difficult time. You have to sacrifice your free time for 2 years, but that lets you in a great school if all goes well, and it also gives you really interesting skills like analytical skills and be able to learn work, and that's stuff you can use your whole life. It doesn't. Yes, sorry.
No, that's okay. I'm just really curious. I mean, so is it self-directed? Are you entirely on your own when you're?
Oh, absolutely not.
Okay.
No. It really looks like school. You've got a math teacher, a physics teacher, a chemistry teacher, even a French teacher. You've got classes. It's just more intense.
And what happens if you do poorly at the end of those 2 years?
Well, you've got a chance to do your second year one more time and take the national exam again, except that you have you don't start at the same ranking. Like you're a bit late because you had more and more year to prepare, so you have a slight disadvantage in terms of ranking, but you can make it up.
And what are I'm sorry that this is actually just something I'm particularly interested in because I've never spoken to someone who's gone through it before, but I have read about it. What's the exam like? So you've been studying intensely for 2 years, giving up 2 years. I mean, in a sense, giving up 2 years of your youth, but also devoting 2 years of your youth to learning. And then you go to this incredibly important exam. How does that work? Is there like a center where everyone from the country goes, or is it regional?
Yeah, it's regional. When I went was right off Paris, and so it's quite early in the morning, and I remember that day there was mist all over the place, and we were like hundreds of us walking towards the center. It was like a bit like The Walking Dead, really, because it was so early in the morning and everyone was a bit stressed out. So that what it looks like. I don't know. What I remember, I think what you feel that day really depends on people. What I remember from it is I wasn't that much stressed out. I mean, I had worked for it so much that what was going to happen was going to happen anyway. So, and like you've rehearsed for that like 100 times over. You've made like 100 fake exams during the year, so you're prepared basically. So you just go and do your stuff and hope for the best. That was how I felt about it, at least.
Yeah, it's really interesting. There's, I think, a parallel from Chinese history of bureaucratic exams that you might be aware of as well, where young men. It was gendered, of course, at the time in medieval Chinese history, but young men from around the country would go to regional schools, and it was actually multiple days. I'm a bit surprised to learn that it's just a one day exam.
Oh, it's not. No. It's clearly multiple days,
okay.
Even multiple weeks, I think, because it's not just one exam with one rankings. You've got like something like 4 or 5 rankings independent from each other, perhaps, and you can take them all, and they all give access to a different set of schools.
And how did it feel to succeed at the end of all that?
It's pretty cool.
I imagine. One thing, this is a bit of a history question, but I mean, the schools like the one you went to were set up to play an important role in sort of the fate of the country. And in the case of your school, bridges and roads and things like that. Originally, when did it start teaching computer science?
To be honest, I don't know. And to be even more honest, I didn't study computer science there.
You didn't? Oh, okay.
No. The first year is about general engineering. You do bit of computer science, but you also do mechanics and maths and probabilities and even a bit of humanities, a bit of everything. And then on your last 2 years, you can choose to like a major, and I chose finance back then. But today I'm in programming, and I use a lot what I learned from those studies I made. And what I use is the analytical skills, the ability to synthesize stuff, to explain it to people, and the ability to learn. And those 3 or 4 things are key, at least in the programming industry, which is the one I know. They're much more valuable than the knowledge about a particular technology that was like hype at the time and that's outdated now. Do you know what I mean?
Yeah, definitely. I've got some questions about how you got into teaching people and communicating to people to help them improve.
Sure.
Before I go there, I just discovered before we started taping this interview that you spent some years in London. How did that come about?
Well, so I majored in finance back in my school, Pont-de-Chaussée, and we have a gap year where you have to go abroad, work somewhere for a year. It's like an internship, but for a year, which is pretty long for an internship. And so I went to London to finance because like London is the place, at least in Europe, to work in finance.
For now.
And yeah, for now. Well, back then it was. So I was working in finance. I was on a trading desk on a big investment bank that was called Commerzbank. And I was doing pricing and that kind of things related to financial products. So that's what I did in London. Then I went back to school in Paris to finish my studies. And then I tried to continue in finance, a different kind of finance. Like what I was doing in London was what we call market finance. It's about stocks and rates and shares, that kind of things. And when I went out of school, I wanted to try another side of finance, which is called corporate finance. It's about like performing financial analysis of companies. To be precise, that was what I got into, was performing analysis of companies that was going to be taken over. It's called due diligences. You probably know about that, Len.
Oh yeah, I did a lot of DD in my merger and acquisitions days in London.
Yeah, right. Yeah. So this particular job was in Paris. It happens, but I'm sure it exists all over the world. And I thoroughly hated it, like every minute of it. And what I didn't like in it was that what was difficult was the working environment. Like people were mean, you had ridiculous hours, you had to face like clients that would be really, mean and not interesting. And the actual job was not so challenging. Like it was just moving numbers around. That was at least my experience. I'm sure that you or someone else can have a completely different experience in that kind of job. That's what happened for me. And that made me realize that this is not the kind of challenge I was interested in. And then I moved to the programming industry, and I used the fact that I knew a bit about programming because that was a hobby, and I was extremely motivated to learn. And that's what really makes the difference in programming again. And I also knew about the software that the company I got in made. It was about finance, about market finance. So I knew a bit my way around a bit. But in the software industry, typically, for most people I've spoken to, and for my experience, the challenge is in the work itself. Like code is challenging. Code is complicated. You have to think hard to get code right. But the working environment, it's not where the difficulty lies. Like people tend to be laid back, and it's a nice place to work usually. And I think that you want your like your challenge is to be in the task itself, you know?
Thanks very much for telling that story. That's really interesting. I didn't think I would be getting the chance today to talk to someone about what it's like to do due diligence. But for those listening, many people may have had the experience, for example, of buying a house, and before you buy the house, you get the house assessed. Imagine you were buying a multi-billion-dollar house. You have to do all kinds of things like check out the insurance, check out the accounting history, check out the environmental situation, things like that. If you're, for example, buying a company with property in Germany, you have to look for World War II ordnance. And all these things it's always very intense. There's usually time pressure. There's a lot of money at stake, and there's a lot of big personalities. But as Jonathan pointed out, once you've done it once or twice, even though it can be highly paid and seem even from the outside a little bit glamorous, the problem itself is actually solved. And you really are just, as Jonathan said, sort of moving numbers around and shuffling papers. And it's funny you say that, because that's actually basically more or less the exact reason I got out of investment banking myself.
Did you?
After 2.5 years, it was like,
okay.
It was like, I actually maybe was one of those guys myself who's not quite so nice. I was fortunate to work in a company with very few assholes, but there was a lot of intensity, which I quite, euphemistically I'm saying intensity, which I quite enjoyed. But the intellectual challenge fades, at least with respect to the straightforward aspect of what you're doing. If you start rising in your career, then all kinds of basically stepping over other people to get ahead challenges come your way, and those actually are genuinely difficult challenges, and they're complex and interesting to some people, but not to everybody.
Right.
And if you don't find the stepping over other people to get ahead part of it interesting, once you've figured out the kind of technical aspect of it, you can just get bored. And so your description of that experience really resonated with me. It's interesting you talk about how your experience in finance informed your ability to communicate to people. And I wanted to ask you, so was there a particular moment when you developed an interest in helping people become kind of better programmers, better at tackling the real challenges?
It didn't happen in one day. Like, I didn't wake up and run around trying to teach people. I think it knowledge builds over time. When you're a developer, you have to keep learning, and it's something nice, because like most developers like learning. So you learn stuff about the language you're coding in, you learn stuff about design, you learn stuff about the domain of your application. You learn stuff all the time, and it builds up. And at some point I had a few things to share, and I think there's really nothing special about that. I think every programmer has something to share. Even younger people, they have probably tips and tricks for other younger people, and senior people have obviously a lot of things to share. So I had my share of things I could tell people, and probably hopefully help with. And so I wanted to get those things around. And the thing is, I wasn't quite fond of traditional trainings, like, the kind of trainings when you go all day or perhaps all week, it's really like disturbing for your work day or work week. And I don't know, but I'm not a really good audience. Like my attention span is fairly limited. I mean, nothing pathological, but I just don't have such a big attention span. So I wanted to give away this knowledge, but in a way that I would have been easy for me to attend, either because that wouldn't disturb so much my day, or because it wasn't so long. So I came up with the idea, and I decided to use it to share whatever knowledge I had at that time. So this is how this is what I proposed to my manager. I asked him if he was okay if I would spend 10 minutes every day right in the office to tell my colleagues a few things I knew about C++ because I had read a couple of books about C++, and that's the language we were using. And it was okay to try it. And the first time I told everyone I would do that, and then the first day I would like stand up and speak up, and that was really awkward. Like someone standing up, speaking up right in the middle of the open space, telling people the things on the whiteboard. So I did it for 10 minutes and asked for feedback, and people found that it was okay. So we did it a second time the following day, and then the third time, and then we kept doing it for weeks and months and years, and I still do it today. And that's something that's become routine in our company. And I had the opportunity to speak about that at conferences or on social networks, or my blog, and I got the word out. And we labeled that dailies because it's something that happens on a daily basis. And so people got into it in my company. I was doing C++, and someone stepped up and did Java, and someone stepped up and did databases, and so on and so forth. And in other companies, they would do that too and post that on social media or tell me about it. And that's nice, really nice thing. Now, to do that, at some point, you may fear you don't have much to say, like holding for every day for years, or that you don't have time to prepare because like some periods of time you've got like a big project or whatever. So we put together a system to avoid that. We broke down the sessions into monthly sessions. Like I would do my daily C++ every day on a different subtopic. I would be obviously a specific thing because it would last for 10 minutes. And then the following day would do something different, and so on for a month or for 3 weeks, or like anywhere between 10 and 20 sessions, say. And then the following month, I would go do the same thing, the same contents, into the desk, the office of another team. Because this is local. The point of it is that you do have to spin your chair, look at the daily, and carry on with your day's works. So that it's not disturbing for your day. That's the whole point of it. So it's local in an office, and I would do the same thing in the office next door, or I mean, whoever would be interested, and then the next office, and so on. And you could like have a rotating scheme over like 6 or 7 months, which gives you a fair amount of time to prepare. Now, for people that don't have time to prepare at all, even for 1 month, I think there's an interesting mapping in terms of format between daily sessions and blog posts. A blog post is generally quite specific on a particular issue or theme or whatever. And the amount of contents you have in a blog post is typically what you can tell in about 10 minutes. So I found that blog posts are a good source of content for feeding dailies. I happen to have a blog as well, and I use the contents of my blog to feed my dailies, but I also use the contents of blog of other people to feed my dailies. And that's a win-win situation because bloggers are all happy when their content is diffused, and the people that makes the daily has contents, and the people that listen to the daily listen to new contents.
I'd like to ask you about your blog in just a second, but before that, I wanted to take the opportunity to ask you about a talk you've developed. So while researching for this interview, I watched a YouTube video of a talk you created called 105 STL Algorithms in Less Than an Hour, which sounds impossible, but anyway, everybody should watch this talk. It's great. So in it, you present a really cool world map of C++ STL algorithms, and you have animations showing how the individual algorithms work. And I have to say, it's the best presentation I've ever seen where the presenter is trying to teach people something about programming. I've seen quite a few. I'm not a programmer myself, but I've seen quite a few sort of researching for other people for this podcast, and no disrespect to any of them. but Jonathan's presentation is something special. And I just wanted to ask you a little bit about how you went about creating that. How did you generate the animations of how algorithms work and what they're doing?
Well, thanks. Well, to answer that direct questions, I use Keynote, which is the equivalent of PowerPoint but for Mac, and I use Blender, which is a piece of software that can make 3D animations. So to answer your first question about
just very specifically, so you've got a lot of this will make sense to people who watch it, but there's a really interesting way of moving boxes around to show how data is being moved by different algorithms. Did you actually use Keynote to do that?
Yeah.
Oh, wow. Okay.
I just use Keynote. I use Blender for, I don't know if you remember, but the first time the map gets on the screen, there's this, I'm not sure if I can call that, but sort of like Game of Thrones thing.
Yes, you can, because it is just like that, yeah.
Yeah, or it has, but it's nowhere near the production level of quality of the game, of the intro of Game of Thrones. But that's the spirit I wanted to give, even though I didn't aim for the same quality. So there's this world map, which looks like a world map, like there's mountains and valleys and stuff and sea. And the cities are the algorithms of the standard library in C++. Just to make it look clear, if you're not a programmer and listening to this show, what we call an STL algorithm in C++ is a piece of code that can operate on a collection of things. Like one typical thing you want to do on a collection of things is to sort them by, I don't know, by size or alphabetical order or whatever. So the algorithms in C++ are pieces of code that can do such things. And there happens to be 105 of them, which are available when you install C++. So the map has, all the nature thing, and the cities on that map are named after the algorithm. So there's a city that's called sort, and there's a city that's called find, and one that's called partition, whatever. And there's all of them on the map. And when the map comes in, there's this effect which I've created with Blender, which is the thing that does 3D animations. It's really not that hard to do. I didn't know Blender before that, and that's my friend Vincent, to which I'm very grateful to, who taught me how to do that, to have a camera that hovers over a plane, essentially, on which you pasted a texture, which is the image of the map. And so the thing goes around, a bit like Game of Thrones. So that's Blender. And the rest of the talk is, like you described, animations about boxes, because you can see a collection as a set of books laid out next to each other. And if you want to sort them, for example, they would move around until getting into their sorted positions. So this, I completely do with Keynote. Keynote is a quite powerful thing when it comes to animations.
Yeah, that's amazing. And just again, for anyone listening, if sorting algorithms sounds boring and obscure, just watch Jonathan's talk. It won't be boring, and it won't be obscure, and it won't take that long. But it really does explain these things very well.
So one more thing about that map to answer one of your questions about how this all came together, all that presentation. There's this opinion that's around the C++ community. It's been around for years. I think it originated in Sean Parent's talk. Sean Parent is a famous C++ developer. He made a few years back, and he explained how important it was to know what was in the STL algorithms. And this talk it went viral. I mean, viral within the proportion of a C++ community, but viral. And so everyone was aware of that. But that quite a few of them, there are 105 of them, and we don't really know them. We know we should know them, but we don't really know them. So that was my topic. Let's once and for all get into that and learn them all. And so that's how I came with the idea of that presentation. Now, how I crafted it, I guess you can imagine that I didn't craft it from day one the way it looks like today. Like, it went through quite a few iterations. And although the actual iterations, I don't think they matter a lot, what I took away from that, and I think it's an interesting takeaway when it comes to making presentations, is the thought process that structured the presentation. When you take the 105 algorithms, it looks like huge lists of code stuff. And that's not something you want to look at, even if you're a programmer and you love code. That's not something you can digest. So the challenge was to make that big chunk of information, to present it in a way that would be easy to digest and to remember. So how I did that is that I looked at them, each one after the other, just to learn those I didn't know at the time. And then I classified them. Like, for each one of them, I would decide in which category it would belong, even though those categories didn't really exist for me before that. For each one, I would say, this is like sorting, this is like finding, this is like whatever. And then I had rough classifications of the algorithms. And from that, I could refine it, like perhaps shuffle them around, create new classes of algorithms. And then I had this big picture, like there are 7 categories of algorithms. 7 is easy to remember. And then within these categories, you had subcategories, like those algorithms, they kind of like relate to each other. So you should think about them together. You should learn them together. And I think that's the value of the presentation. And then when you have this classified information, the challenge is to present this big picture, but not to hide the data. So you want to present the actual data. You don't want to like make something really simple for dummies. You want to present the actual data, but in the big picture form. And then the rest is just the cool stuff, like the map, the realms, the arms. I draw arms for each of the 7 families. That's something that's really nice to do. But that's the thing that makes it nice to watch, do you know what I mean? But the underlying thing is the research of classifying things and presenting stuff with a big picture and not hiding the data.
Yeah, thanks for that. Thanks for that explanation. It's an excellent presentation. You could kind of tell it. It didn't happen overnight, and there was a great deal of work and iteration that went into it. But in the end, it is very almost compelling, and it is quite an achievement to do with that subject matter, which is also actually very important. When did you start your blog, and who is it meant for?
I started my blog about 2.5 years ago. It was in November 2016. It's aimed at developers. And developers who want to make their code more expressive, and by using C++, because the blog uses code examples in C++, even though sometimes it talks about stuff that could be applied in any language. And on that blog, I publish 2 articles a week on Tuesday and Fridays. Every Tuesday, every Friday, you've got a new post. The theme of the blog, writing more expressive code, I chose that because after a few years, I thought that this was the most important quality you want for your code. Like, when you start coding, the thing that matters is for your program to do what you want it to do, right? And then you're just happy with that. But it happens that to make a program do something, there's about 100 ways, 100 different pieces of code you can write, 100 different ways you can write your code to do that thing. And they're not all equally good. And when you write a piece of code, then it's probably going to stay. I mean, if you write it just on the side to try something, you're going to throw it away afterwards. But if you write it and you're like in a company, it's going to stay. It's going to stay for a while, probably, hopefully, like your company is going to stay with its code. And you're going to go back to it. You're going to have to change it at some point because maybe there's a bug in it, or perhaps the client wants a new feature that's related to that piece of code to extend it. And perhaps you are going to do it, or perhaps someone else is going to do it. So the thing that makes work more efficient when it comes to programming, or when it comes to actual code, is to make it so that someone who would read it would understand it. That's what I call expressive. So this is the biggest thing I try to do for my code. And there are a lot of ways to do that. It's not just like one technique to make code expressive, although there are some overarching principles we talk about in the blog. Sorry. But there are 100 ways, and particularly when you dig into the details of a particular language, which are C++. So this is the theme of the blogs, and every post is connected somehow to that theme.
Just before we move on to talk about your book, I have a question about one particular post that you wrote about how you can use lessons from programming to optimize your day-to-day life. And I just thought it was really fun, and I was wondering if you could talk a little bit about that. You talk, for example, about iterating on your morning routine.
Yeah, right. So I'm going to start from the coding perspective, and then I'll move on to the real life perspective. So in programming, it happens sometimes that your program is not fast enough. Happens. To fix that, there is one technique that's really conventional. It's been there for years. So it's to profile it, which means run it through a program that can count how much time the program spent in every instruction it made, or every function. In a program like an industry-sized program, there are like thousands, literally, or perhaps tens or hundreds of thousands of functions that get executed when you run your program. It can be less on smaller projects. And every one of them takes some time. It's really short. It's like in terms of milliseconds, probably, or even less than that. But all adds up, it can make like seconds or minutes, and that gets too long. Even like sometimes milliseconds are too long, depending on your industry, but it can add up and be too long. When you run this kind of analysis, you get a list of functions with their time, and they're sorted in descending order by the amount of time they took. And there is this principle, it's called the 80-20 rule. That's a sort of like proportion that's all over the place in programming or in other domains. I'm sure you've heard about it. I mean, I'm sure that if you have like more than 5 years of experience in any domain, you've probably heard about the 80-20 rule. It says that 20% of the causes trigger 80% of the consequences. That's one way of putting it. And when it comes to software speed, it says that 20% of the code is responsible for 80% of the time. And some go as far as saying it as 90-10. So like 10% of the code is responsible for 90% of the time. So you want to aim for those 10%. And your profiler is going to sort your functions by descending order of time, and those big guys are going to stand out at the beginning, and you want to act on them, like focus your efforts on those big guys. And what you don't want to do is go around and optimize everything, because sometimes by optimizing for speed, you are damaging expressiveness. I'm not going to get into details because it's technical about why there's this relationship, but sometimes it happens. And you want to sacrifice expressiveness only in places that matter, and you want to act on them, right? So to put it into a nutshell, you've got big, responsible guys in your code that take time and you want to aim at them to make your program faster. Right, so that's the code side of things. In my daily life, I noticed that I spent way too much time in the morning to get ready. Like it would take me like 40 to 50 minutes to get out of my home, and I basically just take a shower. So this is ridiculous. I felt I could like save really decent amount of time for every morning, and morning times matters, right? Because you can do stuff in the morning. So I wasn't sure exactly where to begin with, like where exactly I would waste time. I didn't have a feeling of wasting time at particular points in my prep in the morning. So I took a stopwatch and measured everything I would do for those 40 to 50 minutes. The time it took me to brush my teeth, or to dry up in the shower, or to get dressed, or to put on my shoes, or whatever I was doing in the morning. And then I put that into an Excel spreadsheet, sorted them by descending order of time, and then I could see like the big chunks of time I would spend in the morning. And I tried to figure out how I could optimize those specifically, took actions, and now I get ready in like 25 minutes, which is about half of what it was before. And 25 minutes every morning, that's a lot of value, you can imagine. So that's one example, but there are quite a few others.
Yeah, that's a great example. I've just got a flashback. I never was so sort of systematic about it, but back in my days when I used to commute in London, actually, I remember optimizing my morning sort of flow. And I remember one time realizing that if my apple juice box was less than half full, I could just place it on the glass and walk away, and it would fill up the glass, and then the box would go down perfectly flat on the table, and so I could save the time of standing there over the glass and watching it pour, and use that time to do something else. And it was just because I hate mornings. I mean, that's not like I just hate mornings so much that it was like I'm going to attack this problem. So moving on to the subject of your thanks for that, by the way. That's just so fantastic to hear about using techniques like that to improve your daily routine. On the subject of your book, so for those listening who might not know, and for those who I guess might be triggered by it, you can skip this section, but what's legacy code?
Right. So everyone has kind of a different definition of legacy code, but they all mean something bad. The general gist of legacy code is existing code that's painful to work with. That's the general idea. My definition, because I wrote a book about that, so I had to have a precise definition, it's threefold. First, it's code that's hard for you to understand. Like you stare at it and it takes you a while to figure out what it's supposed to be doing. Second, it's code that you're not comfortable changing because you feel you might break something, or because you need really time to figure out how to integrate a new thing into the existing stuff. And third, it's code that you're somehow concerned with. It's code that you have to interact with in some way. Like you don't really care about code that's outside of your company. It's not legacy code as far as you're concerned, in my definition. There are quite a few other definitions out there. There's a famous one from Michael Feathers, which is a really famous person in the software industry, in particular when it comes to legacy code. So Michael Feathers defines legacy code as code without tests, because you can test code automatically. You can write code that tests code. So when you change your code, you can launch a program that's going to test it for you and assure you that you didn't break anything. So that's Michael's definition. It's legacy code is code without tests. There are quite a few other definitions out there. Some people feel like legacy code is the code that was there in a company before they got in. But yeah, essentially it's around the same theme. I hope that clarifies.
It does. I'm just curious. So would Feathers' definition be kind of like historically contingent based on the idea that code used to be written without tests, and that it's only now that it's becoming more conventional to write tests along with code? I ask this from a position of ignorance. I really don't know.
Sure. I think, yeah, there's that, because I think we've become more aware of the necessity of testing after we became aware of the necessity of programming. Although we've, like, speaking as an industry level, we test stuff. We've been doing that for quite a while. Like test, it's something that's around for decades probably. But there's code that predates that as well. But it's not completely correlated. Like you have code that's produced today that doesn't have tests. And when I say test, I mean automatic test. Like when you write your piece of code, it can be tested by a human on the day you release it, and it can be tested again at some point. But the test I'm speaking the test Michael is speaking about is, as far as I understand, tests that run automatically. So there's code that gets produced every day, and doesn't have that kind of test coverage. The reason is that, as surprising as it can sound, it's not something that's adopted by everyone. Like some people, I've met. I go to conferences, I go to meetups, and I get to speak with people, and they tell me about how it's like in their company. And like there are some people, not necessarily technical people, perhaps managers, I don't know, that are not really fond of spending time testing. Because when you write a test, you're not actually delivering a new feature, or you're not fixing a bug, you're just writing something for the future. And like investing in the future for the future doesn't pay off on day one, or very, very little. So you have to think a bit long term, even though it's not that long usually for your test to pay off. So some people have a hard time convincing the managers they should spend time in doing tests. Also, if you are convinced and your manager is convinced that you like testing is a good thing, sometimes it's difficult to achieve, because to write a test, you have to write a program that's able to encompass the code you want to test. And sometimes it happens, and that's particularly true in legacy code typically, that some code is connected with other pieces of code you don't want in your test because they're not related, and connected in a bad way, I should say, like tangled with other parts of the code. So isolating a piece of code can be challenging and time consuming, and sometimes that's the reason why you can't really write a test, or not easily.
One of the things I really liked about your book was that you make managing your feelings when you're faced with legacy code the very first topic that you address. What is it about, for those who might not know, what is it about legacy code that can make it so emotionally repulsive to programmers?
Well, the first thing is, if you start programming as a hobby, and that's the case for quite a lot of people, like we do that out of passion, code in companies doesn't look like what you do on your side project. Like if you write a game, a text-based adventure game, and you had your fun, professional code doesn't look like that. When you get in a code base of a company that's been there for, I don't know, like a few months or a few years, you've got this huge amount of code that's completely loaded with domain information that you need to somehow work with, right? And it really doesn't look like what you were doing when you were a student and you had your pet project or your uni project, and it was small and you had everything under control and you would understand every part of it. So you get into that, and there's this difference that can be unexpected, right? So that's I think the first thing that can make it a bit surprising. It's not a bad thing though. Like all through the book, I think that one of the messages I want to get across is that legacy code is not something. It's not a fatality, if you know what I mean. It's something you can work with. That if you happen to have legacy code, there are 100 of ways to work with it, and that's what I explained in the book. You can do fantastic things with legacy code, but you need to be prepared. You need to have tools to do that. And when you're just out of school and you've never heard about that, yeah, it can be a bit of a shock. One thing that can make it frustrating to work with legacy code is that it can be hard to understand. By definition, if you stick to the definition I gave earlier, and understanding is something that's quite rewarding in programming. And if you don't understand, well, it's not that rewarding, so it can be a bit frustrating. And what makes it hard to understand is that, like we said when we were talking about tests, is that sometimes you've got parts of code that are tangled together. So when you investigate one of them, it relates to something that can be a bit far away. So you need to understand also that remote part, and you need to somehow make all this fit in your head. And when there's a lot, it's challenging. You can take it as an intellectual challenge, or you can just be overwhelmed, and that's one of the things that makes it emotional. Do you know what I mean? Also, there's this quite natural feeling is when you come across codes and you think you see a flaw in it, you're tempted to think, well, the person who wrote it didn't know what they were doing. Right, so they designed something poorly, and you have to bear the consequences today. Right, and that can also be a bit frustrating. Although I think this is a completely wrong view, and you have to change your view to be able to work with legacy code.
And what can you do to manage your attitude and change your view when you're sitting there facing something? Because I've had some similar experience with complicated financial modeling. I mean, there's a lot more to mergers and acquisitions than due diligence, and one of those things is dealing with all kinds of complicated modeling. And I know what it's like to all of a sudden be in front of someone's messy work. Mm. That getting into the right attitude is tricky.
Sure. Well, the first thing is to escape that primal attitude of judging the code, saying, oh, this is terrible, I would have done such a better job, and I don't understand anything to this crap, and I need to get out here. You need to escape this attitude. The reason is, if you think a bit rationally, and programmers are paid to think rationally, that's about our job. Well, first of all, this code is what makes the application run. You can question its quality, but that's what pays your bills. Basically, that's why your clients like you. That's what makes the application exist. That's what made it develop in its first years, and that what made it grow and allowed it to exist today, first of all. But then when you think that you would have done such a better job, it might be true, or perhaps you wouldn't. Perhaps the particular problem the person who wrote the code was trying to solve is more complicated than meets the eye, and if you were to do it again, you would face the same difficulties than they did, and you would realize it was much harder than you thought it would. So maybe the person who wrote it, you can't really blame them, or not blame them as much as you thought. Now, the thing is, the most rational thing to think is that this is the code out there. If you have to work with legacy code, you can't change it by snapping your fingers. You can either moan and cry all day and not produce anything and get fired, or you can make the most of it. And like I said earlier, you can make a lot of things with it. You can make fantastic things with whatever code you get to work with, or pretty much, I think. That's at least my opinion. So the first thing when you came in on your first day, and something you have to hold, I think, for your whole career, is do not complain unless you want to improve the code, right? And your complaining is directed towards specific things you want to improve or you want to learn from. But otherwise, just complain for the sake of it. It doesn't bring anything, and it will make you more depressed, if anything. And what's even more dangerous is that it will make your neighbors more depressed, and particularly if they're younger, right? I think that's something we need to realize when you're in a company and you've been there for, I don't know, even more than a year, and let alone 5 years or 10 years, you are a model for the people next to you that are younger, right? Because they came in and they don't know what the culture's like. If it's their first job, they don't know what working is like, I mean, in the professional sense of it. So they're going to watch you. And if you spend your day moaning, they're going to think it's okay to do that. And that's the only thing you can do. And they're going to moan as well, right? So when you complain, you have a huge responsibility. So it doesn't bring anything unless this is specifically to improve the code. And it can really be damaging. So just don't do it, right? Be rational. So that's the first thing. Now, once you left that primal attitude, you need to find a way to work with the code, right? So there are plenty of specific things to do. I go into details in the book, but essentially the attitude is to take ownership. At least that's my opinion. It's what my manager told me fairly early on in my first year of professional programming. He told me that when you have to work on a piece of code, you have to take ownership of it, even if you didn't write it yourself, right? Maybe that's someone who wrote it. Maybe that person wrote it 20 years ago, right? Now this is your code, right? And that's your job to work with it, to improve it, to do whatever you can to make the most of it. And thinking in that perspective makes you more responsible and empowers you really to work with it in the most effective manner, I think. So yeah, the second thing is to take ownership.
And you write about how you can actually use legacy code to improve your own programming skill.
Sure, yes. So that's the part when I say don't complain unless you want to improve the code. So if you find a piece of code that you don't like, it happens quite often. Read code that you're like, man, not sure this is the best code I've ever seen, or this is crap, or whatever how you want to put it. Well, what you can do is just walk past, right, and go to the next thing. Or another option, and I think it's much more interesting, is to think about why you don't like it. What in it makes it wrong or makes it of not good quality? And when you start thinking about it, surprisingly, sometimes the answer is not quite obvious. Like sometimes you've got this feeling that, I don't like this code. And when you look at it, you can't really point your finger at what's wrong exactly with it. And that requires a bit of thinking, like decomposing it in your head, trying to locate what exactly gives you this feeling about what's wrong about it. And at some point, you manage to find exactly what it is, right? And even if you just move on, you've learned something. You've learned what to pay attention to. And this is valuable because when you are going to write your own code afterwards, you will have that in mind, this particular aspect of code quality, and you're going to get it right. right? And the more time it took to dig it out, the more it means that you didn't know about it, and the more you learn. Now, one option was to move on after learning that, but you can also improve it. That's called refactoring. That's a very common term in the programming industry. Refactoring means improving the quality of the code by keeping the application behavior constant. So once you've found what's wrong about that piece of code, you can choose to refactor it. You can't refactor everything, particularly if you're working on a large code base and you have to make some choices. Or I'm not going to get into that right now because there's a lot of things to consider, but that's what I talk about in one of the chapters of the book. But imagine you've chose to refactor that particular piece of code. So you've improved it. Right. What's tempting to do is to move on, considering you've done a good job, you've improved the quality of the code. But what you can do before moving on is think back about what exactly you improved, like why the new piece of code is better than the old one. Sometimes you can tell it's better just by looking at it, but once again, not really being able to pinpoint what's better. So you need to do the same kind of analysis. Just think about what's changed and how it's better, so that you can use that in your future code. The analogy I used for that kind of analysis is the vaccine. So a vaccine, like in medicine, is something you get into your body, a very small quantity or a harmless quantity of a disease, and your body spends some time deconstructing it, examining it, whatever, building antibodies, whatever, and stores that somewhere in its memory. It remembers it, so that when you, if it happens, encounter the actual disease, your body recognizes it instantly and smash it apart in no time. I think this analogy holds for code because after you spent time analyzing this wrong piece of code in excruciating details, and you found what's wrong with it and you remember it, when you encounter that same problem in existing code or when you're about to write code, you're going to smash it apart. You're going to smash that problem apart in no time as well.
Yeah, I love that analogy, and I think it's related to the concept of expressive code because expressive code leaves the memory behind of the problems that have been solved. Is that correct?
Yeah, I think there's that to it. There's quite a few things, including this. Yeah.
Mm-hmm. Yeah, it's really interesting, and you brought up before. Sometimes it can be hard, maybe I've interviewed people who've expressed a similar idea before that, convincing a manager that you should spend time testing can be difficult because they're often tapping their watch and they want forward progress. But as you also said, it actually doesn't always take that long before you realize that there was actually a lot of value in testing. And I just wanted to ask you specifically, so, I mean, you came up with the concept of the dailies, expressive code is important to you, and these things, and, this vaccine analogy about preserving solutions for the future is all very important. And I was wondering if you could talk a little about how that kind of knowledge can be spread throughout a team and remembered for the future, like our immune systems do with vaccines.
Sure. Well, one obvious option is going through writing, like writing documentation. The thing is, generally, there's this trend amongst programmers that people don't like writing documentation. Like you like writing code, you choose that job because you love writing code, but writing documentation, not interesting. The thing is, I think there are various ways to write documentations. Some of them are boring and useless indeed, and some of them are really useful for you and for the rest of the team. Well, first of all, when you write about something, or even when you explain something orally, that works as well, you, by some magic, understand it better. Even though no one taught you anything while you were explaining it, the very fact of putting it together, structuring it, teaches you stuff. It makes you realize things, makes you get the big picture view, makes you realize that there are holes in your understanding and makes you dig deeper. So the very fact of writing is helpful for yourself and obviously for the team as well. Now, there are good, useful, precious documentation, and there are boring and useless documentation. How can you do your documentation right? I think there's a lot to it, but one of the heuristics I found is that you need to realize that writing documentation is not a moral obligation. You don't do it because it's a good thing. And what follows out of that is you shouldn't write documentation as if it were homework. You should write your documentation as if you were explaining something to your past self. I don't know if I'm making sense here, but it really shows, when you read a document that's been written like if it was homework, it really shows, and you don't want to read that, and that's just as boring as reading as it was writing. But if you write something to your past self, then you have to be clear, you have to be effective, because you know that your past self didn't know what you're writing about. Now, about the specific format, if it's something very generic that you discovered, if you've discovered, something about class design, object-oriented programming, how to make your if statement look right, how to make your program faster, whatever, that's very generic, then write it on a blog. Start your blog if you don't know one. Having a blog is pretty awesome. So write it to the world and let people know and start discussions about what you found. Now, if it's specific to your company, what you've discovered, well, the first thing is to put it somewhere you can find them, not on your mailbox, not on your computer. But I think a good place to put it is next to the code. Code is usually stored into version repositories, like with Git, for example. If you don't know Git, that doesn't matter. But if you know Git, you know what I'm talking about. But code is stored somewhere, and storing documentation next to the code makes it easy to find it and makes it easier to make it not too much out of sync with code. That's also an interesting thing to think about, how to make it not out of sync with code, because that's one of the problems of documentations. People that don't like documentation have this problem with it, that they sometimes read documentation that's out of date, and it's worse than having nothing, because it's misleading, right? It tells you information that's wrong. So you need to find ways to write about something that's not going to get out of date, but that's still useful. There are a few examples that I could get into now, or that, anyway, I talk about that in the book, in the Legacy Code Programmer's Toolbox. Mm-hmm. Also, if you go further into that, making code and documentation closer, what we do typically with code is code reviews. Code review is after you've written a piece of code, you show it to everyone in the team, or to at least one people. Most versioning systems like Git or whatever have this completely automatized. It's a process. It's really easy to do, and then you can show the code to people, and they can comment on your code saying, "Are you sure you want to do that? Or isn't that a bug? Or maybe we can improve the quality of that new code." So that's what we do. Best practice of doing code. You can do the same thing with documentation, right? You can send it around the team and ask for feedback, and people are going to say, "Are you sure this is information is correct?" Or even more importantly, "I don't quite understand what you're trying to say here. Could you clarify?" And this helps make your your writing clearer. And make it clear is tremendously important, because if you want it to be read, it has to be readable. It has to be clear, because otherwise people are just not going to bother. Now, there are quite a few other ways, apart from writing, that you can spread knowledge. Dailies are a way, of course, but you can also do what I call knowledge sharing in eager mode and lazy mode. So that's another analogy with programming. So an eager computation is a computation you make ahead of time, just in case someone needs it and it's ready, so that you don't spend time computing it when it's needed, right? You don't so that the application doesn't freeze or whatever. So that's eager mode. How you can apply it with documentation is to spread your knowledge before people need it. Like what you can do try to do that with some of my teammates, and that was really great. Have somebody speak, make just a small meeting, just a team meeting, and have someone speak about what they know on a specific topic, right? Even though this is not something someone asks specifically, but that's just something they know, and they had trouble perhaps understanding, or that they know it would be useful, and that someone is going to come across it one day or the other, and they just make a small informal presentation, nothing too fancy, just telling what you know. And I call that eager, because you do that ahead of time. Now, in programming, you have eager mode and lazy mode. Lazy mode is doing the minimal amount of computation and leaving the computation to the last moment to compute just what is needed and nothing more. This is the idea behind lazy computation. I think you can do lazy documentation by knowing who to ask, right? And the day you need this information, if ever you need it one day, you know who to ask. So how do you know who to ask? Well, of course, it comes with experience. You get to know people, you get to know what they work on. But you can speed up that process by having people actively telling what they know about, without getting into details, without getting about explaining how things work, just saying, I know about such and such topics because I've worked on them, right? And you go around the table on team meetings, everyone spend 5 seconds telling what they know about, and they would be available to speak about if needed. There's in the agile methodology, there's the stand-up meeting, typically in the morning, where people of a team gather and speak about what they do. It's not made for documentation, obviously, but that can be a side effect for lazy documentation, because you hear about what everyone is doing, so you kind of have a basic idea about who would know what. But I think it's still useful to have this active approach of expressing what you know about.
Yeah, it's the concept of sort of documentation for people who aren't into programming might sound a little bit in the weedsy, but I've had some experience. It seems the experience I've had talking to people on this podcast about things like documentation and these types of processes, the more serious the work they're doing and the more senior they get, the more these things start to matter. I remember interviewing somebody who had at one point in his career been working for a very fast-growing online gambling company, and he actually took out months and months to do proper documentation. And it was extremely serious work and extremely important, because if there's actually serious money at stake in sort of these second by second transactions happening all the time. And he ended up being the chief software architect for a major British bank. Anyways, as he's there are people who sort of don't like testing. There are people who don't like documentation, but in my experience, it's people who take those things seriously. For any young programmers listening, it's people who take those things seriously who maybe go far. My last question about your book, you write that you love, maybe this is related to what I was just saying, or I hope it is, but you write that you love doing code maintenance. And that's not something that most people sort of boast about. And I was wondering if you could talk a little bit about why you
Sure.
like doing that.
Yeah. So let's just explain what that means in case someone is listening and not sure what maintenance is. So producing a piece of software goes through about two phases. There's the time you develop it, so it doesn't exist and then it exists. And that's the first phase. You release it, and then it lives, and people use it, and people go back to you because they want to change it. They want to change it because there are bugs, for example. They want to change it because they want to add stuff, for example. So the maintenance I was thinking about here is like when you're fixing bugs. Like a client goes back to you, say, this doesn't quite work properly. Could you fix that for me, please? Generally, developers are not really fans of making maintenance. That can vary, obviously, from people to people, but from person to person. But it's a bit like documentation, not quite as much. Documentation I think it's much more frowned upon, but maintenance is, yes, definitely not the number one activity. I happen to quite like it, which may sound a bit weird, but why do I like it? It's because I find it's a bit like a game, really. Like, you know that some part of the application is not working properly. Like a small, I don't know, like something is not displayed the right amount or whatever. And this can be either rewarding or frustrating. Depends on how you tackle the thing. The thing is that you have to find in that huge amount of code where exactly lies the source of that problem, right? And that can be quite a challenge. So if you just roam around and look at the code and search for something that's wrong in the code that's related to that feature that's not working properly, it's a nightmare, really. It's like just wandering around and in desperation. So I think that's probably why people don't find it interesting. Now, if you have a process to locate the source of a bug, then it just becomes a matter of time. And there is a process. I'm not sure we've got the time right now to get into it, but it's in two of the chapters actually of the book. I could go into it if you want, but it's a bit long-ish.
Maybe if you just briefly explain it, but we want people to be buying your book, so.
Right. So essentially, the first thing is not to look at the code. It sounds a bit weird because the problem is in the code, but you don't want to look at the code. You want to play around with the application. You want to somehow isolate the problem from the application perspective. You want to test it around and with some specific processes. I'm not going to go into this level of details, but you want to play around with the application to find where exactly what subpart of the big feature is wrong, has the bug. And then you go in the code to that specific position with a hypothesis in mind. Maybe this is the right place to look at. And you look at it, and if you've made a good job reducing the size of the problem, then you've got not so much code to look at. So that's like huge amount of code you don't have to look at. And if you don't know that code, if it's code that's hard to understand, that's just as much you've saved. And you check if it's the right hypothesis, and if it is, then cool. And if it's not, then you go back to the application and change a bit the parameters and so on. And when you have this approach, and you've done it enough times that it becomes a second nature, maintenance is like a game, because it's just a matter of time before you really track down the source of the issue. Sometimes it's not the case. In very exceptional cases, there are other factors at play, more technical, whatever. But in most of the cases I've encountered, this is how you want to be efficient. And that really makes the experience much faster and much more rewarding. Well, if we can like take a step back about what we've just said about maintenance, we've just said about documentation, even what we've just said about legacy code, there are parts in the job of being a programmer that people don't find nice, like maintenance, writing documentation, handling code that someone else wrote. These are not popular activities. But if you want to, like you say, go far, you have to embrace them because this is your job. You can't just do part of your job. You can't just say, well, I like writing new code and that's it. There's no such job, right? Programming has a full spectrum of activities that in the end contribute to make your product awesome. Right, and you want to be part of the largest part you can, and even if this involves maintenance and documentation and reading code that you didn't write yourself, that's something you want to be excellent at because that's your job, and that's what will get you far.
It's really interesting to me that you talk about the part where you're using the app to kind of isolate the problem as closely as you can as a game. Because that's actually personally how I approach it. When with LeanPub, when we're sort of doing a big release, one of the steps near the end is like, "Len, go break it." And I've always tried to approach, as a non-programmer, like I have to figure out conceptually, like how can I make sure that it's not two problems, it's just one problem that I've isolated, and have I done all the other things to make sure that it is just this one problem and not something else. But it is very much like a game that actually is enjoyable. It's like it's enjoyable for me because I'm not the one who actually has to fix them. I'm just find them. But it is actually an enjoyable activity and as you say at the end, and as you said earlier, the reason you're here in the first place is because there's some code out there that's working, at least a little bit, and that's a good way to approach what you're doing to start from that foundation. So just moving on to the last part of the interview, and so where we talk about being an author and writing, I wanted to ask you how you found out about LeanPub and why you chose LeanPub as your platform.
Sure. I first heard about LeanPub because I heard about a book that's on LeanPub. That book is called Living Documentation. It's written by Cyril Martrare. It's actually about writing code documentation. So that's how I heard about you guys. Now, when I decided to get into the project of writing a book and self-publish it, I looked around for different options, including LeanPub, and I think I had quite good feedback about you guys, and quite terrible feedback about some of your competitors. Really, like I went on forums, and I'm not sure I want to name names about your competitors here, but like some people got emotional with some of the other people out there. So yeah, LeanPub looked fine. And I don't know, perhaps I can also answer that question after the fact. Like now that I know LeanPub, why would I advise my past self to choose it? One of the great things you guys have is your support. You've got a fantastic support. I was absolutely impressed. Like whenever I had a problem with that technical about generating my PDF or feedback about the platform or whatever, I would just shoot you an email and you would answer within the day or half a day or even a few hours sometimes. And like one evening just before the big release, I had a like kind of emergency with my book, and I think it was you, Len. Yeah, you answered like within, I don't know, half an hour, something like that, and we solved the problem. And that really matters in that moment, because this is like a big moment and you don't want to screw that up. So I want to thank you for that, by the way.
Oh, well, thanks. I mean, the one thing I'll say is that we do try to have very good support. One of the things that I'm particularly sensitive to is that when an author writes a book, it's a labor of love and time, and it's based on things they've thought about a great deal, and they often have great hopes for what they're doing. And I think this might be related to, I mean, I've talked to some people who got emotional about their experience with publishers and other platforms, and it comes from that same space. That what you're doing is really, when you're writing a book, probably what you're doing is very important. Maybe it's more important to you even than it ought to be. But when it comes to launch time and things like that, when you feel like you may have lost work or something like that, when you've just done a big chunk and something's not working, we're a small team. We're not always going to be there 24/7. But, I can say personally, like, I don't care if it's like midnight and I've had a couple of beers, and if I see like an author's having a problem, I will, personally try and help them, because like that, that's really important, and it is a personal thing.
Yeah, it really shows, and I think it matters a lot. What I also appreciate is your landing pages, because they are so simple. Like when you look at them, you've got the cover in big size and a bit of blurb, and you've got this cursor, which I find really awesome. Like people can pay the price they want, basically. There's a suggested price, a minimum price, and you can pay whatever you want as long as it's as least equal to the minimum price. And I think that's really cool. That's a cool feature.
Yeah, that in particular, for anyone who's listening who doesn't know, LeanPub has a variable pricing model, which means that an author sets a suggested price and a minimum price for their book, and then a reader, a potential customer, can take their mouse and they can actually move this slider around, so they can take it from the suggested price and move it to the minimum price, or they can move it even higher. And one thing we found after releasing that feature years ago was that people would be to kind of boast, because LeanPub pays such a high royalty rate, we can also show the author earns slider underneath the you're paying slider, and people actually move the author earns slider. Sometimes that's actually more important to them than what they're actually paying in the end. They're like, I want to make sure the author gets $10 or $20 or whatever it is out of this. And it actually does, I have this feeling that it really does change the relationship that the customer has to what they're doing in comparison to a sort of normal commercial transaction.
Mm-hmm.
Just a couple more questions about your book.
Sure.
One is engaging directly with people who have already bought your book important to you? For example, getting feedback about things like typos.
Oh, yeah, absolutely. In the very last section of my book, there's the getting feedback thing. Like I leave my email address and I welcome any piece of feedback about the book. And I'm absolutely interested in chatting with people about the book or about the topic of the book in general. Like I want to know my readers' problems, basically, with legacy code, to see if I can bring more, or I don't know, perhaps adjust the book that it's the most useful to them, and it really makes an impact in their daily life working.
So this has been almost a feature-length interview now. So I'm going to jump to my last question, which I always like to ask of authors, which is, if there was one thing we could fix for you on LeanPub, or one thing we could build for you, and we would do whatever you asked, what would you ask us to do?
Sure. There's a couple of things.
Okay.
Should I choose just one?
No.
Can
Please,
I say a couple?
Please.
Okay.
Ahead, yeah.
Right. Well, there's got a few people have asked me about paper printing. Like, it would have been fantastic for them to choose either the PDF or the printed version of the book, and to have it delivered to their mailbox. That would be perfect for them. Now, I realize this is probably hard to implement if you're not Amazon or whatever, but at least as a workaround, I know that you guys make available a PDF that's nicely formatted to go to Lulu or Amazon or whatever, but it would be nice to have a very detailed step-by-step basis to, as an author, how do I get my paper print out? Like, on which website do I go? How do I do that? Am I involved in any storage or whatever? How much money would I get paid? Like, really detailed things, because we don't know. Like, I have no idea how I should do that. Really, like, should I do it myself? Should I organize the printing and give out copies to the people I meet in real life, or should I go on Amazon? How much money would I make on Amazon? Will I be even like seen at all on Amazon? how do I do that technically? On which website do I go? Where should I subscribe? That's like 1,000 questions I'm asking, and I have no idea. And to be honest, I'm not really interested in digging out for myself. And I think if you make a tutorial, it could help like hundreds of authors with just one document. So that would be my first suggestion. The second one is it relates to the Markua. I'm not sure I'm pronouncing that correctly.
Markua.
Markua, sorry. So the Markua, for people that don't know, is correct me if I'm wrong, a specific flavor of Markdown. So Markdown is sort of a formatting language, like you can type your text, and when you want like say a word to be in bold, you surround it with 2 stars, for example. So you'll write plain text, but you sort of embed the formatting information in it. So that's the gist of Markdown. Markua is a specific flavor of Markdown. So I had a bit of trouble really getting everything right, like the images size and getting code in the text and having line numbers or not line numbers. And for some reason, the thing would just not do what I would ask. So I didn't ask correctly, obviously, but I wish it were a bit simpler to format the book with Markua and perhaps show tutorials. I mean, I know there's a super long page explaining the Markua thing, but I feel I could swear I did exactly what was on the page, and for some reason it didn't just give the right result.
Thanks for both of those pieces of feedback. When it comes to using LeanPub, something you've written on LeanPub to then go and make print versions available. We do have a print ready PDF, but we actually don't explain how to do it. We're just like, go to Lulu or go to Amazon, and we provide you with all the details of the things you're sort of going to need, but we don't really place them in the context of a bigger story about what you're doing. So we give you everything you need, but we don't exactly explain. We don't actually explain like why precisely this here. That's a really good suggestion, and I'll put it on my list of things to do to make a post. And maybe, in fact, probably even a better thing to do would be in our next author newsletter. We'll just invite someone to write a guest post about their experience doing that, because it's kind of hard won knowledge when you've gone through it.
Right.
And when it comes to Markua is not fully implemented yet, so it doesn't have a sort of full proper manual like old-time LeanPub flavored Markdown does. So right now, Markua is more of a technical specification than a manual. And one day we will have a manual that explains things not in a sort of like as though you were building your own Markua processor way, but as in a like I'm writing a book kind of way. And that should make it easier when it comes to, I swear I did things exactly right. It didn't work out in the end. I have that feeling as well with all kinds of things. And hopefully when we have a sort of proper kind of manual rather than a specification, that will be less common in experience.
I understand. There's one last suggestion I wanted to make. It's about the online editor. So on ENPUB, you can choose either to write your book online on the website of ENPUB. There's a bit like a kind of WordPress thing, like you've got the text field where you can type in your book, or you can write it on your own and upload it somewhere on the internet, like on a repository like Bitbucket, for example. And there's another one that it's probably GitHub. And LeanPub somehow connect with this online repo and pulls out the book. So about the online editor, initially I wanted to use that because I felt it was all at the same place and it would make things convenient, because all the settings of your books have to be on the LeanPub website. So I thought the book might just as well be there as well. So I went for that as well at first. And I had to move away from it and go for the Bitbucket thing or GitHub, because it doesn't handle versioning. So if I change something, I lose, well, I think at least I lose what was before, and that's a bit scary, in terms of UX, I think there are quite a few things you could do to make it more friendly. I don't know if it's a good example, but I use WordPress for my blog, and I found their interface excellent. The old one, the new one, Gutenberg, is a catastrophe in my opinion. But if you know the old one, it's awesome.
Yeah, thanks for the straightforward feedback. I actually, it's a bit of a digression, but I have heard about Gutenberg being a catastrophe from WordPress users, people who use that to write their blogs. Our in-browser editor, there are two. There's one called a visual editor, which is for people writing genre fiction, and I'm pretty sure that's probably not the one you're using. You're probably using the Markua one. It's something that we intend to improve both of them, but in particular, the Markua in-browser editor is something we know that we need to do. There's so much room for UX improvement there. With respect to versioning, every time you create a preview or publish a new version, we actually do save a version of your manuscript.
Oh, do you?
If you go to your books URL and then at LeanPub and then /versions, you'll see it. It's in the menu also when you're in your book tools. But we actually do save a version of your manuscript. It's you need to kind of download it and then look at it. So it's nothing like proper Git or anything like that. But like I was saying before, being sensitive to how much authors can be afraid of losing work and stuff like that. We've got this versions thing. Every time you create a preview or publish, we save a version of your manuscript for you, so that if all is lost, that is still there. So there's internal to LeanPub. There's no comparing. There's no diffing and stuff like that. But those manuscript versions are saved.
Cool.
And if you're really so thanks for that.
I don't obviously don't have to say, but perhaps you may want to, I don't know, hide it altogether until it gets a better UX, because for me it was just a not so good part of the experience, and when I moved away to Bitbucket I felt much better. So now you have to know how to use Bitbucket to be able to use it. So I guess maybe you have authors that don't write about programming and are not familiar with it, but
it's thanks for that, Noah. We really appreciate hearing about not every people are often overly polite and don't tell you about the bad parts of their experience, and so it's we know that part of LeanPub could use a lot of improvement and that it's not the best, and I think that just watching sort of our statistics, more and more people over time are becoming familiar with services like GitHub and Bitbucket, and how powerful they are. And so most people actually, when they see that they've got an option to use GitHub and Bitbucket, they just kind of ignore our in-browser Markua. If they want to write in plain text and learn a new markup, they're probably going to be sophisticated enough or whatever to be using to be desiring to use something like GitHub and Bitbucket anyway, which is why we don't encounter this issue so often. I'm just guessing, but I'm guessing people just probably just don't try it.
So you mean that the online editor would be mostly used for people that write novels?
So there's two online editors. There's the one that's where you write in plain text in Markua, and then there's another one where it's actually a WYSIWYG. What you see is a editor, and that one is just that one's mostly for you can't upload images in that mode, and that's it's very deliberate. It's like if you pick up a Dickens novel, probably actually, that's probably a bad example because a lot of them did have images. But if you pick up a conventional genre fiction novel, there's probably no pictures in it. There's probably no underlining in it. There might not even be any italics. There's just words in paragraphs. And so we made what we call a visual editor to be precisely for that experience. But separate from that, in browser, you can also write in plain text in Markua if you want to. But that's the one that you're describing that, needs a lot of work.
Okay.
And that is sort of on our list of things to do.
Right.
Okay. Well, Jonathan, thank you very much for taking the time to do this and so much time. I really appreciate that. This is all sort of, we covered a lot of ground, which is very useful, but it's also, of course, very useful for us. And one of the reasons LeanPub advances is because authors like you take the time to give us feedback like you did at the end of this interview. So we really appreciate that.
Sure.
Thanks very much.
Thank you.
Thanks. And thanks as always to all of you for listening to this episode of the Lean Pub Front Matter podcast. If you liked what you heard, please rate and review us on iTunes. And if you're interested in becoming a Lean Pub author yourself, creating a book or a course, please go to leanpub.com and click on Why Lean Pub.